Hey, I'm Daniel. I'm developer advocate for IPFS, and today I'm going to talk a little bit about onboarding more developers to libp2p with the Universal Connectivity app. I spend a lot of time thinking about how we can grow our developer community, especially in IPFS land, and I think there's a strong case to be made for doing that also for the libp2p community. So let's get right in. Okay, so I'm going to talk about really three things. What is the Universal Connectivity app, and why it was built, some of the challenges that I think are still out there for onboarding more developers to libp2p, and then we'll do a quick demo. So what and why? So the Universal Connectivity app is really just a chat app that is showcasing all of the different libp2p transports, so WebTransport, WebSockets, WebRTC Direct, and WebRTC, also QUIC. And it has three implementations, three peer implementations in Go, JS, and Rust. And it's using Gossip Sub for the messaging. And you can see on the right-hand side, this is the kind of topology that you can create. So in order to make this work, especially for browsers, we have a Go and a Rust kind of bootstrap appears that are always running. And the reason that we have both of them is because WebTransport is still only supported in Go libp2p, and WebRTC Direct is supported in Rust. I believe it's going to be landing soon in Go. And so that means that depending on the browser you're using, you might only be able to connect to one of these bootstrappers. So Firefox still doesn't have support for WebTransport, and Chrome has support for both WebRTC. So, I mean, a Firefox node will just use the WebRTC direct connection to the Rust peer. And so really it just started with me because I'm mostly focused on IPFS, but I really wanted to learn how libp2p works, and really with a strong focus on what's possible in the browser. And this started at IPFS thing when our very own Martin gave a talk about challenges in browser connectivity, and he showed this table. And at the time, it was interesting, if you can see, the only real option there was WebSockets. And there's a pretty big problem with WebSockets, especially if we're trying to build these kind of self-certifying systems that don't rely on authority figures, namely that WebSockets require a TLS certificate. And so that's a bit of a bummer. And so we were quite lucky, I think, with the WebTransport spec coming out and allowing you to do cert hashes so that you can essentially do away with the need for these certificate hashes while still be able to establish like a secure connection. So, I mean, today we're in a much better place with WebTransport, WebRTC. And really, I think there's a very strong case to be made about targeting the web platform. So, you know, we have about 5.3 billion internet users, and most of them, the lowest common denominator for a web user is the browser. And, you know, so I think some of you may have seen this. All of these blockchains and networks are relying on libp2p, and you know, we can think of this as you know, the head tail. Sorry, the head of popularity. So all of these massive users, but very few of them. And I think there's a strong case to be made for the long tail, all of the sort of developers who are just trying to experiment and create weird and quirky apps that might be, you know, that might be able to use libp2p. And I think Universal Connectivity is a great educational resource. It certainly helped me learn a lot of these concepts in libp2p. And if we think of libp2p as a project that we want to get more popular and get it into the hands of more developers, I think there's a strong case to be made there. And it could be an educational resource. It already is in many ways. And so some of the sort of spontaneous things that we've seen happen is that someone just went ahead and created a pull request to add file sharing. And he built his own protocol built on top of Gossip Sub to do that. And another one is that I think is worth mentioning, this is kind of like a yet to be explored opportunity, is this whole idea of some of you may be familiar with like the local first software movement that is really starting to gain a lot of traction amongst developers. Now, local first software is sort of introducing it is beyond the scope of this talk, but I think the headline for it is your data in spite of the cloud. So building software that works locally, it sort of emerged from also the offline first movement. And really one of the sort of most critical building blocks for building local first software is really CRDTs, which are conflict-free resolution data types. These are these unique data types that allow you to essentially make changes concurrently and then converge in a deterministic manner, which is very useful if you're trying to build sort of collaborative software that also works offline and can then reconcile state in a way where everyone sort of sees the same end result. So that's what I mean by deterministic. And the thing about CRDTs like auto merge and many others is that in most cases, network communication for them is an orthogonal problem that they often don't choose to even solve. And so even in the original sort of local first paper by Ink and Switch, they say that, you know, we haven't solved this. They looked into doing it with IPFS. I think in the original paper, they landed on using DAT, which is now hypercore. And so again, this is yet another opportunity, given how powerful libp2p is today and how far ahead it is compared to any other sort of library that attempts to universally solve peer-to-peer networking. And so this sort of leads us to some of the challenges that I think are still very present in terms of onboarding developers. And the first one is if you're coming from Web 2 and you're familiar with the client-server model, you can find it quite challenging to absorb all of these peer-to-peer concepts, you know, auto-NAT, NAT hole punching, multi-adders, peer routing, Kademlia, I mean, just to name. Another one is ephemeral cert hashes. And so if you're building a browser app that you want to kind of like work flawlessly out of the box, you have to connect to someone in order to discover other peers. And so I think even if you're building like a decentralized peer-to-peer app that is sort of targeted at web users, you still need someone to sort of, you still follow some kind of like a hub and spoke model where you have some of these long-running nodes that are serving as bootstrappers. I mean, almost all networks that are relying on libp2p rely on some form of a bootstrapper. And I think a good way to sort of, a mental model for me to think about this is that the resource consumption scales logarithmically in terms of the number of users. So each user that connects to a bootstrapper doesn't really consume that many resources. It just does a bit of like light work to do some coordination and, you know, whether that's NAT hole punching or just telling you about other peers in the network. The challenge is if you only have WebTransport, WebTransport relies on these ephemeral certificates that have to be rotated, I believe, every 2 weeks. And so the multi-adder, I think, contains here 2 cert hashes, so it's good maybe for a month. But if you're sort of deploying a web app, then you need to either hard code this multi-adder or you alternatively hard code maybe a peer ID. But if you're hard coding a peer ID, then how do you go from the peer ID to the multi-adder? And so in that case, you probably need a node that has like a TLS certificate and then connect over WebSockets in order to do that mapping from the peer ID to the multi-adder. I'm sure there's many alternatives. You know, you can do it maybe with HTTP and something like the delegated routing API. I think that's something more from IPFS land, but it's really just solving this idea of doing peer routing over HTTP. I believe this is only a problem with WebTransport. So if you're doing WebRTC Direct, WebRTC Direct uses TLS certificates, and I believe they're not ephemeral. And the cool thing is they don't have to be one of the trusted certificate. They don't have to be generated by one of the trusted certificate authorities. And yeah, as I mentioned, yeah, we can do it maybe after or now. Okay. Another one is, I sort of touched about this, is like peer discovery is challenging in these small topologies. And that is this idea of like you wanted to rely as little as possible on the bootstrappers. And for that, you want to establish as much connectivity between the peers in the network specifically the browser peers, because once they discover each other, they can reestablish connectivity. Say if you reload the browser tab, assuming that they're both online, because they store each other's multi-adders in the peer store without going to the bootstrapper. Now, the problem is that we don't actually have a protocol for ambient peer discovery. We have Kademlia. Kademlia is really useful if you have sort of a bigger network, but if you have a smaller network topology that is mostly centered around browser nodes don't really make for great Kademlia peers because they're very short-lived. And so we have the Rendezvous peer discovery protocol, but the problem with the Rendezvous peer discovery protocol is that it requires each browser to sort of register itself with the Rendezvous sort of peer, and that doesn't really work perfectly for this type of topology. And so there's a PR for that. There's already a PR sort of in the specs repo, but I think there's a lot of reluctance in merging that kind of spec now, because then it requires the burden of maintaining that spec. But still, I think we're going to try to experiment and just do this, implement this ambient peer discovery just for the purposes of this app and see where we can take it. Another challenge is debugging WebRTC. So, if you've done like browser web development and you're familiar with WebSockets, it's pretty neat. You can just sort of open the network tab and, suss out what's happening. With HTTP, it's obviously the easiest, but the moment that you're in WebRTC land, you've got a screenshot there of like the debug screen from Chrome for WebRTC. And I always just lose myself when I open that one up, so I give up. But maybe I just need to work on my engineering skills. Another one is multi-adders can be super confusing. So I would love it if someone can actually tell me what's the difference between these two. I know that one of them is essentially a circuit relay connection to another peer, and the other is a direct one. But yeah, both of these are multi-adders for the same peer. One of them is just going through like a circuit relay through a WebRTC direct connection, as far as I understand. But yeah, please help me with this one. Again, all of these challenges are soluble, but if we're thinking about like onboarding more developers, I think we really need to like tackle these challenges on different fronts, and that includes more documentation, more examples, maybe better abstractions. I heard an argument made that the other day, actually in the context of IPFS, that in order to get IPFS into the hands of more people, maybe all we need is just, a situation where you're just adding a single library and a bunch of lines of code, and then, you're essentially doing some form of content addressing, especially in the context of apps and tools and software that are already doing sort of hashes, hash-based addressing, essentially content addressing, things like Git, package managers, and so on. And so I think there's really a strong case for repackaging a lot of the stuff that we're doing for specific types of use cases that maybe have a lot of demand for, and then coming up with better abstractions. And finally, new protocols, whether that's the ambient peer discovery or other things that seem necessary for whatever you're building. We have a PR that has sort of been sitting around for a while in the docs, and I think landing it would lay a lot of that groundwork to onboard more of these developers. And now I'd like to do a demo. So you've got the QR code, or you can open up the URL. Let's take this for a spin. I would also like to thank all of the libp2p maintainers who've helped with the universal connectivity app. So I just started sort of the browser node and the Go peer, but there was so much help from Chad and Thomas and Discordian and Prithvi. I don't want to miss anyone, but really, like, if you just look at the number of contributors, there's quite a few. So anyways, I'm going to open up the browser now. And what you see here is this is like the landing page, and you will see probably two peers. The two first peers that you see here, these are these bootstrappers that I mentioned. And I can already see that there's more and more peers connecting. You can actually already go to the chat tab, and you can you'll see there's a heartbeat message that is coming from the Rust peer. Hey Chad, hey Doug. If I go back to here, then we've got 7 peers. And I've also, just because I was curious to see how many resources are consumed by the bootstrappers. Okay, the Rust peer is running high, but the Go peer isn't even flinching. It seems, yeah, interesting.
Is the peer on your laptop?
No, so the long-running bootstrapper peer is running on DigitalOcean just because it's easier. There's no NAT hole punching necessary and firewalls or whatnot. Are all of you actually able to connect? Is anyone unable? What browser are you using? Chrome, okay. Okay, that's good. Let's see if you get this message. I think last time someone tried to do something like this, just to see if we're doing proper escaping. But that doesn't work. There's proper escaping. Yeah. Is the connection encrypted? Yes, absolutely. So, I mean, all libp2p connections are encrypted. I believe most of them are using noise, even though libp2p supports either noise or TLS, I believe, for the stream encryption. Noise, I believe, is lighter, but again, I'm by no means an expert on sort of the intricate details of that. You also had a question earlier.
Oh, sorry. Hey, my name is Ryan/Mac/RPM. Why are the web transport cert things a problem? Like with stuff like Let's Encrypt, we can just I can just get new TLS certs all the time. So why is like the 2-week thing an issue for libp2p? And then I just did a demo at ZooConnect, and I was talking to you in the universal connectivity repo about this whole problem, your ambient thing. I finally understood what you're saying because I popped the demo and nobody could discover each other. You have to copy the multi-adders in. So I now understand what you're talking about.
Okay, I'm glad. Thank you, by the way, for getting that node up there.
The demo failed because when you're doing stuff like this, you don't want to have to copy and paste multi-adders to join. You want everybody to just be on the same DHT. But the question is about WebTransport with the certs, because it wasn't clear in the code base here, outside of Rust, how do you even do the cert handshake if you don't have TLS? But even if I did understand that, why is it a problem? Just Let's Encrypt, get a new TLS cert. Or why can't libp2p just do new cert hashes every whatever?
Great question. Did you want to answer it?
No, I shouldn't answer this. I don't know if...
I can try to give a background for how I understand the problem.
That's what I heard from you talking about. That's an issue you guys.
Yeah, I mean, so first of all, TLS certificates are only necessary for WebRTC. And for WebRTC, they don't need to be from an accepted certificate authority. So this is really the ephemeral certificates are only a problem for WebTransport. That's actually a requirement of the WebTransport RFC, that these certificates change. And so that's why you can't if you hard code it, then you have to update it. And so the only alternative is you just hard code a peer ID, but then you have another problem because now you need to do peer routing.
Your multi-addr has the cert hash in it and needs to change it.
Exactly. And so, well, yeah, right now it is hard coded. So in the code, you can see in the constants, you see there's these two. And that basically has to be changed. For WebRTC, it doesn't actually have to be changed. So it contains a certificate hash, but it's not ephemeral. It's permanent. Yeah, go on.
No, I think he answered the question correctly. I was wondering, do you think if we integrate better with DNS, we can somehow improve the situation?
Say again?
So do you think if we integrate better with DNS, we can somehow improve the situation?
Yeah, absolutely. I mean, so the idea there would be to use like a DNS multi-addr and then update the certificate hash. So in the app, you hard code a DNS address that doesn't change, but then you update the DNS record every time the certificate hash changes. sure. I mean, but you're just pushing the problem elsewhere. I mean, it's not a bad solution, but it's better probably.
Wouldn't it be an idea to put it on IPFS somewhere, the hash?
Yeah, so I mean, the hash changes, the hash changes, and so if you put it on IPFS, then you'll get a new SID. IPNS, did you say?
Yeah, maybe.
Yeah, sure, great.
But then libp2p depends on IPFS.
Yeah, I mean, it's like you're starting to add a lot of round trips. I'm not necessarily against it, but it's like you're just pushing the mutability problem elsewhere.
Thank you.
Any other last questions here for Daniel? Great. Well, I just wanted to say, like, I think this experience has been really good for the libp2p community to like really be putting all the pieces together and seeing where things break down or don't work as well as want. So thank you to Daniel and others who've been like pushing on this. I think there's still more fruit to obviously shake out from this, but thank you, Daniel.
Yeah,
for
thank you.
showcasing it. Claps to Daniel.
Tiny feature request, if anyone wants to add it to this awesome connectivity demo, it'd be really useful to have like debug why it's not working for me sorts of error messages and or steps. I can still see all of my own posts and I could see my posts up there. I couldn't see anyone else's posts and I have no idea why. And so I would love the debug features.
Thank you.